Good evening and welcome to the third part of projectile motion. In previous lectures, we have discussed we will break the projectile into two perpendicular independent directions x and y, and we'll discuss both the directions or motion in both the directions independently. Then we discussed three important parameters. First is time of flight, 2u sine theta by g. Theta is angle of projection from horizontal. Then maximum height, u square sine square theta by 2g. And last is the horizontal range, which is u square sine 2 theta by g. Now taking a few questions which are based on these simple concepts. Question 1 is, a particle thrown at angle 30 degree with vertical. This is very important. हमने जितने भी फॉर्मूला यहाँ पर पढ़े हैं इन सब में जो एंगल हम ले रहे हैं दैट इज फ्रॉम हॉरिजॉन्टल. सो प्लीज डू टेक केयर कि कहीं एंगल वर्टिकल से तो नहीं दिया हो. एंगल 30 डिग्री विद वर्टिकल. फाइंड मैक्सिमम हाइट, रेंज एंड टाइम ऑफ फ्लाइट. Solution. As we know that the angle is taken from vertical and we need to take the angle from horizontal. So this is the direction of initial velocity u and this angle is taken as 30. So the angle which we will take is 60 degree because we have to take the angle from horizontal. Time of flight ka formula is 2u sine theta by g. Let's take initial velocity as 20 meter per second and we'll take g for the sake of convenience, g equal to 10 meter per second square. That means t equal to 2, u is 20 sine not 30 but 60 upon 10. G ki jagah we'll take 10. Hence we get e equal to, so it will give us 2. 4 into sine 60, that is root 3 by 2, 2 root 3 second. The second one is horizontal range. Second one is, let's say, maximum height. The formula is u square sine square theta by 2g. That means maximum height is 20 square sine square theta. We know that sine square theta means sine theta the whole square upon 2 into 10. So on solving, we will get 400 into root 3 by 2 the whole square upon 20. So it will give us 20. So this will be 20 into 3 by 4 and this is 5 into 3, that is 15 meter. And the last one is horizontal range, which is equal to u square sine 2 theta. Remember, it is not sine square theta now. In horizontal range, it is sine 2 theta upon g. That means range is equal to u square, that means 20 the whole square sine 2 into, again theta is 60 upon 10. Now sine 2 into 60, that means sine 120. Sine 120. Sine 120 is equal to root 3 by 2. But अगर आप sin 120 नहीं जानते हैं तो you can use the formula sin 2 theta equal to 2 sin theta into cos theta. That means sin 2 into 60 equal to 2 into sin 60 into cos 60, which will give us sin 2 into 60 equal to 2 into sin 60 is root 3 by 2, cos 60 is 1 by 2. So again, we will get root 3 by 2. That means horizontal range is 400 into root 3 by 2 upon 10. It will become 20 root 3 meter. So this was a question which is based on a very basic formula of time of flight and range and maximum height. Now the next question. The question is, a boy is standing on a moving wagon. Wagon is moving horizontally with 40 meter per second. The boy throws a ball up with 20 meter per second. Question 1. Will the boy be able to catch the ball? Question 2. If yes, then after what time? And third, also find the distance traveled by wagon in that time. Also find the distance traveled by wagon in that time. So first of all, let's understand the situation. The situation is, here's the wagon moving forward with 40 meter per second. And here's the boy. The boy is throwing the ball up with 20 meter per second. नाउ द बेसिक अंडरस्टैंडिंग इज सर कि बॉल ऊपर जाएगी और जितनी देर में बॉल नीचे आएगी उतनी देर में तो ये बॉय और ये वैगन दोनों आगे निकल चुके होंगे, तो बॉल प्रोबेबली बॉय के पीछे गिरेगी, तो द बॉय विल नॉट बी एबल टू कैच द बॉल. लेकिन नाउ द पॉइंट इन दिस क्वेश्चन इज व्हेन द बॉय थ्रोज द बॉल अप, the ball will get the velocity of wagon also. That means the ball will not only have initial velocity as 20 meter per second in upward direction, but it also has 40 meter per second horizontal, that means forward velocity. And the boy also has a velocity of 40 meter per second. That means the ball and the boy both will be moving horizontally with 40 meter per second constant speed. However, ball ki vertical velocity will keep on changing because we know that acceleration is there in y direction, but there is no acceleration in x direction. So x direction mein velocity will remain constant. Projectile ki x direction mein velocity will remain constant. So in this case, the situation will be something like that ki ball will move on a projectile path. And as the ball will move on a projectile path, जब बॉल यहाँ पर होगी तो बॉय बिल्कुल इसके नीचे यहाँ पर होगा. जब बॉल यहाँ होगी तो बॉय अगेन बिल्कुल इसके नीचे इधर होगा. बॉय इज मूविंग ओनली हॉरिजॉन्टली and the ball is also moving with 40 meter per second in horizontal direction. So neither ball nor boy will be moving at a greater speed. दोनों same speed से चल रहे होंगे in horizontal direction, I'm saying. And finally the boy will be able to catch the ball. I hope it is clear to all of you. I hope it is clear to all of you. So first, will the boy be able to catch the ball? The answer is yes. And if yes, after what time? Now we need to find the time of flight. क्योंकि जो टाइम ऑफ फ्लाइट है जहां से बॉल फेंकी गई है और जहां पर कैच की है वही समय हमसे पूछा है. सो इन दिस केस वी विल यूज द फॉर्मूला 2u sin थीटा बाय g. लेकिन सर यहाँ पर तो हमें u भी नहीं पता है और थीटा भी नहीं पता है. However, we can calculate that. We can apply this formula, but we will apply this formula in this case here. Let's solve it using both the methods. Now, as the ball has velocity 40 meter per second in forward direction and initial 20 meter per second in upward direction. So the net velocity of ball will be like this, which will be equal to, according to vector, 40 square plus 20 square. So that will be under root of 2000 meter per second. That will be 2000 meter per second. We can write it as 20 root 5 meter per second also. And what about angle? Angle भी यहाँ पे easily हम calculate कर सकते हैं, because as we can see the triangle, this is 20, this is 40, and this is 20 root 5. So if we need sin theta is 20 upon 20 root 5, that is 1 by root 5. If we will need cos theta will be base upon hypotenuse, that will be 2 by root 5. And in case we need tan theta, however हमें नहीं जरूरत पड़ेगी, तो tan theta will be 20 by 40, that is 1 by 2. So now first, time of flight is, if we apply 2u sin theta by g, so we will get t equal to 2 into u is 20 root 5, sin theta is 1 by root 5 upon g, which is equal to 10. So t will become, ये 10 से 10 यहाँ पर गया, रूट 5 से रूट 5 भी गया, दैट इज 4 सेकेंड. ऑल्टरनेट मेथड आपको याद होगा, मैंने आपको फॉर्मूला 2u sin थीटा बाय g लिखवाया था टाइम ऑफ फ्लाइट का, बट उसके साथ मैंने आपको ये भी कहा था कि रिमेंबर दिस फॉर्मूला आल्सो, t इक्वल टू 2u by g. इफ वील अप्लाई 2u by g, देन व्हाट विल गेट, व्हाट इज u by? u is इनिशियल वेलोसिटी इन y डायरेक्शन व्हिच इज डायरेक्टली गिवन टू अस. यहाँ पर आप इस बात को समझिए कि हमें u y और ux डायरेक्टली दिए हुए हैं. ux is 40, uy is 20. So 2 into 20 by 10, which will again give us 4 seconds. So the answer is 4 seconds. Similarly, if we need to find horizontal range, range का formula was u square sin 2 theta by g. एक बार चेक करें इसको. Yes, range का formula is u square sin 2 theta by g. So we can write it as u square into 2 into sin theta into cos theta by g. U square is again u was I guess 20 root 5. Yes, u is 20 root 5. So 20 root 5 square into 2 sin theta is 1 by root 5, cos theta is 2 by root 5 upon g is 10. That means overall range will be 2000 into 4 root 5 into root 5 is 5 into 10. So 200 by 5 is 40 into 4 160 meter. But again alternative method. Let me remind you हमने एक फॉर्मूला और पढ़ा था रेंज का which was 2ux uy by g. So if we'll apply range equal to 2ux uy by g, and this will be easier in this case. Ux is 40, uy is 20 upon 10. So it will again become 160 मीटर. सो आई रिकमेंड यू, आप याद रखिए बिल्कुल कि टाइम ऑफ लाइट इज 2u sin थीटा बाय g, लेकिन ये भी याद रखिए कि इट इज 2uy बाय g. आप बिल्कुल याद रखिए कि हॉरिजॉन्टल रेंज इज u स्क्वायर sin 2 थीटा बाय g, बट ये भी याद रखिए कि इट इज 2ux uy बाय g. नाउ